Good morning. So in this class we are going to see about the different methods of multiplexing which is used for the wireless communication related to satellite. And multiplexing, we know that multiplexing means breaking up the higher speed circuits into several lower circuits. In general, multiplexing means it is an abbreviation for many into one, right? So whatever the entire spectrum or the frequency resources available as a queues, that can be split up into the different subdomains, and it can be used for the communication by the different subscriber. That is the meaning for multiplexing. The main advantage of multiplexing is the cost. Multiplexing is cheaper because fewer network circuits are needed, right? Since we have divided the entire spectrum into subspectrum and with the numbers, so that can be used for the fewer communication equipments can be used. And here there are four types of multiplexing: FDM, TDM, STDM and WDM. WDM, it is a wavelength division multiplexing. Frequency division multiplexing means here the available frequency available larger single spectrum as a frequency band has been divided into number of the smaller band. That's why it is called as frequency division multiplexing. That means the available single resources frequency as a huge frequency band that is divided into number of smaller frequency band. That's why it is called as FDM, which is nothing but a frequency division multiplexing. And the frequency division multiplexing is generally called as the dividing the circuits in horizontal, right? And in order to prevent the interferences between the channels, we have generally used guard band inserted in between the two consecutive sub bands in order to avoid the interferences between the consecutive channels. It is actually the wastage of bandwidth which is used to separate the channels, two consecutive channels. So because of the guard band, some band or some frequency range of in FDM has been wasted. Right. CATV use FDM. FDM is commonly used to multiply telephone signals before digital transmission because the common channel is used, and here and it is still used as the older transmission line. And this is a circuit configuration for the frequency division multiplexing. Here we have the many signals has been combined into the single signal by using the frequency division multiplexing, and that combined signal has been transmitted over the circuit. And in the we have used the demultiplexing concept, which is reverse that of the FDM to convert the single stream into the multiple data stream. And the next one is the time division multiplexing, which is nothing but TDM, which is used to multiple channels to be used by allowing the channels to send data by taking turns, right? So as similar to the FDM, what we have done to divide the single spectrum into number of frequencies band, here the single spectrum is converted into time slot. The total time slot has been divided into number of time slot, and each and every time slot has been assigned to the individual user. So the TDM has been generally referred as the dividing the spectrum or divided the resources in vertical manner, right? So here we have the picture representation where we have the four subscribers has used the single channel by using the TDM constant with its ABCD here, right? So here we have used the TDM, so that is used to carry the four different subscribers data over a single resources. Then in the receiver side, here after the demultiplexing, it has been segregated into the four respective channels. And the next one is the STDM, which is nothing but statistical time division multiplexing. So here the time division multiplexing and statistical time division multiplexing difference is, here STDM is designed to make use of the ideal time created when the terminal is not used in the multiplexer. Whereas here in the regular TDM, here the regular TDM, here depending upon the number of subscriber and available time slot has been divided, and it is allotted to the individual subscriber, right? So it is only the allocation, but if the particular time slot is not used by the respective assigned subscriber, means it is a totally wasted one. So here in order to avoid these limitations, we can go for STDM, which is nothing but statistical time division multiplexing. Here the time slot allocation is only based on the request from the individual subscriber, right? So the assignment is done based on the needed by the different terminals on the multiplexer circuits, right? So since the source of data channel is not identified by the time slot it occupied, additional addressing information must be needed for STDM. If all the channels try to use the demultiplex circuit intensively, response time delay can be occur. So this multiplexer needs to contain some memory to store the data in case more data samples come in than it outgoing circuit capability can be handled in accordingly. So this is a vectorial representation for statistical time division multiplexing. So here the statistical time division multiplexing, it is only based on the requirement from the individual subscriber. The next one is the wavelength division multiplexing, that is mainly used in the optical fiber using LED or laser as a source of light. Here it is used previously for the single frequency transmission with a typical data transmission rate of 622 Mbps. With WDM, data is transferred at several different frequencies over the same fiber. That is the meaning. And here later we have the additional version of the WDM, which is called as DWDM, which is nothing but dense wavelength data transmission, where we can have the higher data rate up to 110 Gbps, right? So that is the meaning for DWDM. At present, research is going on to increase this data rate also, that 10 Gbps also. And here the next inverse multiplexing. Inverse multiplexing, instead of using a single line, an inverse multiplexers share the load by sending the multiplexed data over the two or more line, right? This is the concept of, right? Instead of transmitting the multiplexed data over a single load line, why can't we divide the multiplexed data into more than two lines? That is the meaning for inverse multiplexing. So here T1 line can be used to send the data, creating the combined multiplexed capacity 2 into 1.545. Instead of having single load lines of this much capacity, why can't we divide that single load into two different loads having this much of capacity? That is the meaning for the inverse multiplexing concept, right? So this is the meaning for inverse multiplexing. Thank you.